Hi guys, and welcome back to EasyPy 3. In this lesson you will learn how to do calculations on Python using arithmetic operators. But what are operators? Well, operators are special symbols which are able to perform operations on values, in this case mathematical. Some of them you may be already familiar with, such as the addition, subtraction, multiplication, and division signs. Other symbols you may not have come across before, such as floor division, modulo, and exponent. Don't worry too much if you don't know any of them. We will now go through each of them in more detail. Let's start with the standard arithmetic operators, which you most likely know. The first two are addition and subtraction. Have a look at the screen on the right. As you can see, the Python shell can be used as a calculator. Also note that if a float is used, the result will always be a float. This is an implicit conversion, which we spoke about in the previous lesson. Another thing to note about plus and minus signs are that they are both binary and unary operators, unlike the rest, which are only binary. What do we mean by that? Well, let's look at the following example. In this case, the first plus is unary in that it only applies to one value, the number 4. Next, we have the first minus, and this is a binary minus. By that, we mean it applies to both values, the one on the left of it and the one on the right of it. Next, we have another minus, but this is a unary minus, in that it only applies to the 2. Whilst there is nothing wrong with writing plus sign in front of the 4, it is not needed, so we don't normally write it. The other two well-known operators are multiplication with asterisk or star sign and division with a / sign. If you look on the right, you can see multiplication follows the same rules as the previous two in converting integers to float when floats are introduced. However, if you now look at division, you will see that division always produces floats, even when there are no floats used. Okay, so we saw that the standard division operator always produces a float, but we may not want that, in which case we use floor division. The double / operator differs from the standard single in a couple of ways. As you can see on the right, it only results in a float when a float is used, which fits the norm. Floor division also results in no fractional parts. Let's look at integers first. If we use this operator on integers only, there will be no fractional parts. Now see what happens if we use a float. It results in a float, but the float is always equal to 0. Floor division always rounds down to the lesser integer, hence the name floor. Look at the following code on the right. What do you think the result will be? The result is -3 because -3 is lesser than -2. Next we have the modulo operator. This is also known as a remainder operator. As the name suggests, it results in a remainder left after the integer division. You may think, what's the percent sign got to do with division? Well, don't look at it as a percent sign, rather a division sign / with empty circles to fill. Let's do an example. If we try 10 modulo 3, we get 1. Why is that? Well, if we do 10 floor division 3, we get 3. This tells us that as a whole, 3 can only go into 10 thrice, which takes it to 9. So we have 1 left over, hence remainder. If we do 10 modulo 5, we get 0. Why? Because 5 can go into 10 as a whole twice without anything left over. The modulo operator follows the norm in producing floats when floats are used. The final thing to remember when it comes to division is that you can't do division by 0, neither can you do floor division by 0, and you can't find the remainder of a division by 0. Finally, we have the exponent operator. This is used for when we want to raise something to the power of something. You have the base on the left of the double asterisks, and you have the exponent on the right of the double asterisks. So 4 double asterisk 2 is the same as 4 superscript 2, which is how it's normally seen in maths. If you look at the screen on the right, you will see that once again, if there is a float type being used, the result will be a float.
Spacing can be used for any of the operators.
Okay, so another thing you need to know about these operators is that some have priority over others. You may be familiar with BIDMAS or BODMAS. which is the standard order in maths. This also applies to Python too. Look at the table presented. It contains the priority of the operators, with priority 1 being the highest and 4 being the lowest. You may ask, what if operators have the same priority level? How will it work? Well, for all except 1, it will be left-sided binding. What does that mean? For example, if we do 15 modulo 4 modulo 2, it gives us 1. This means that it's calculated from left to right. So first it did 15 modulo 4, which gives 3, and then it did 3 modulo 2, which gives us 1. Had it been done from right to left, we would have got an error, as you can't divide by 0. The only exception is exponent, where it is right-sided binding. For example, 4 exponent 3 exponent 2 gives us 262114. Now to confirm that, we do 3 to the power of 2, which gives 9, and then 4 to the power 9, which gives us the same result. Had it been left-sided binding, we would have got 4096. On a final point, the priority order can be changed by using parentheses or brackets, as we know from BIDMAS. Brackets override everything else. For example, in the standard order, 5 times 3 plus 5, you would get 20. But if we add brackets around 3 plus 5, we now get 40, because now it does 5 times 8. Okay, so I know we've covered a lot of maths, but it is really important. So if you got it, well done. That's really great. And if you haven't got it, not to worry, go back, keep practicing. And if you still don't understand something, you can always send me a question. And remember, you can always use the Python shell to practice things you've learned. Next up is a practice exercise for you to try.